All right, hey everybody. Thanks for joining us. Sorry we're a little bit late, but we're just getting started now. My name's Brett Little. I'm the Executive Director at the Green Home Institute, and welcome to our first ever Facebook Live broadcast as part of our online education series that we're doing. Real quick, if you don't know who we are, the Green Home Institute is a nonprofit organization with a mission to empower people to make healthier and more sustainable choices in the renovation and the construction of the places we live. We're headquartered in Grand Rapids, Michigan, and we oversee training, education, and green building certification throughout the Midwest. I'm here today with the designer and architect of this project, Michael Carlson, as well as Greg Mulder from Kauffman Electrical, who worked on the solar. And then the builders, True North Homes, right?
Homes by True North.
Homes by True North. Alex here, who's going to be talking about the construction of the process. So we're going to be doing a virtual tour for all of you to join us. Come on inside. As we're going throughout this, please don't hesitate to ask any questions. And our communications director, who's manning the camera, Angela Top, say hi, Angela.
Hello.
Is going to be facilitating the questions and getting those answered. So we're going to be going through about another hour here, and at this point I'm going to just real quick have our other presenters just quickly introduce themselves and then their business, and then we'll get going. So why don't we start with you, Greg?
Kauffman Electrical Equipment. We basically supplied the solar system. See on the roof here, it's a 7,200 watt system. Basically should provide most of the power for the house. And we also work on integrating high efficiency LEDs and high efficiency heating equipment in designing net zero homes.
I'm Alex Guzin with Homes by True North, and we were the builder for the project.
And I'm Michael Carlson, Carlson Studio Architecture. We were the architecture firm that did the project. We're based in actually Sarasota, Florida, with the offices in Seattle, Washington as well, and we are licensed in 5 states, so we work up in Michigan and enjoy working in different climates actually. So we're 20 years old this year, Carlson Studio is, and we're happy to be here with Brett to see this house.
So you've had a LEED project before in Florida. Can you just briefly tell us about what you've done with that?
Yeah, we have. So we this is our famous project for our firm. We did the HGTV house, the 2009 Green Home, which is in Stuart, Florida, and it's a LEED Platinum certified home. It was our first Platinum home, and it was really fun to work with HGTV and go through all of that. It was the first project HGTV ever certified through LEED, so it was really cool.
Great. So this house is, if you're wondering where you are, or where this is at, we're in, for you energy folks out there, we're in climate zone 5, what meaning that can get to you.
It's important.
So not as frigid as 6, but definitely a colder climate zone, certainly not temperate. This particular house, we are just south of Grand Rapids, Michigan, in a more rural area as to where you might be located. And I believe this is sort of rural, not quite rural, because it looks like we're in more of a suburban sort of area, correct?
It is, but there's no density here, for sure.
There's no connectivity, right?
No, there's no connectivity to public transit or anything like that, and there's not really any density. We're on a small lake just south of Grand Rapids.
Yeah, and one thing that you want to note is that this project is pending for Platinum.
Correct.
Right, that's what it's going for. And a lot of times folks believe that Platinum projects have to be in urban, dense areas to pick up a lot of those location points for busing, biking, community resources. But I think this kind of goes in the face that if you put your resources into other areas such as energy efficiency and water conservation and site and community, that you can have a nice LEED Platinum home that's not in an urban area.
Yeah,
and
absolutely.
So we'll show you that there today. So real quick, you can take a look at the house and you can see that we've got solar energy at the top. You might be able to see it a little bit up there. So Michael, why don't you talk to us a little bit about the commitment of using the sun both in a passive and through photovoltaics for this project?
Sure. It's really the key to the design solution is the passive solar features, and then we supplement it able to put PV on the proper roof area. So you're looking at the south face of the house, but the main body of the house actually faces about 35 degrees west of south, and that was the lot we were given, and that's the views to the lake. So panels are, there's this funky shaped roof up there. It's kind of trapezoidal, it looks like, from down here. And what we did with the design is we actually took the biggest area of roof and we rotated it 20 degrees to the south. So that main roof area up there is actually within 15 degrees now of due south, which is an underlying LEED criteria. You don't get a credit for that in our particular case, but we'd like to see the PV within 15 degrees of due south. So it actually, besides giving us great exposure to the sun all the time, all year round, it made the house, twisting the house 20 degrees in the middle of the house, created beautiful, very cool spaces inside. So it does do what it wants to do passively, but we also utilized it to really create beautiful indoor spaces that are a little bit, they're not rectilinear like you're used to in a regular house. So when we go inside, you're going to see these dynamic spaces, these ceilings that don't, they rise from low to high, but they do it at a different angle than this room is down below, so it really works out well. Energy Star shingles, you can see the white shingles to keep the heat from coming in the house. And all this south-facing roof, you could actually add more PV on this house in the future as costs come down and things, everything works better in PV. And so anyway, so this is the southern exposure. Lots of roofs, lots of potential. We did actually choose not to do solar thermal. We're actually making energy through the PV that supplements the house and creates the electricity to heat the water. And that was I think Greg suggested in the end, it was that the solar thermal wasn't necessarily a great solution in this particular house, but we could have done it, and we still could do it in the future as that becomes more cost effective as well.
Correct.
So, I mean, it's really the key to the design is the passive solar orientation and being solar ready and putting just over 7 kW of PV
7
on that
kW.
roof.
Yeah,
So-
can you tell us a
Yeah,
little
the
bit about
actual-
these solar panels?
These are basically made in Michigan panels. They're actually made in Traverse City, or just south of Traverse City. And they're basically 300 watt, 72 cell panels. They're in 2 strings, so that we basically maximize the strings. We're using a low voltage startup inverter with maximized strings, so we basically are getting the most power that we can out of the system. We did, when we actually looking at a solar thermal, we actually had a solar thermal system that we can actually put on the bottom of the panels, so you don't have a separate racking issue. It just, based on the way the usage of the house and how it was being used, just didn't quite make economic sense.
And so I see you actually have some extra space on the roof, so you were saying there might be an ability in the future to add more solar if you needed to. Is that something that can be plugged in pretty easily?
Yeah,
or-
basically could easily put in a second system underneath the existing system once we find, but a lot of it is also based on the energy efficiency of the house. We may actually find that it's not necessary. So it basically makes more sense to see where the power is, usage is, and then because this should produce close to 8,000 kilowatt hours a year.
There is actually a metal roof under the PV panels as well,
Right.
which is a much longer lasting roof system.
True.
It's more expensive, obviously. Metal is more expensive in the front end, but it's actually less expensive in the long term through the life cycle cost. But we did choose to put it under the PV panel so it would be there for longer than the PV panel, so you would never have to remove the PV panels, change out the shingles,
Yeah.
put the PV panels back up. The metal roof will be there forever.
And
so.
typically those metal roofs have recycled content in them.
Yeah,
and
yeah.
Like you said, they're gonna last forever there.
Yeah.
And the PV panels are designed so that the warranty on them is they're produce up to 80% of their power for 25 to 30 years. And they will continue to produce power beyond that. So you really, when you're looking at PV, you want to design a roof that's designed for at least a 30 to 40-year life, so you don't have to take them down the road, because it is a permanent design.
Yeah.
So Is it really the metal roof kind of because of the PV there? Because I see, you know, you've got shingles on the rest of the house. Was it more of just so you didn't have to replace that?
Right.
Is that?
Well, ideally, if we had an unlimited budget, we would
Right,
put metal
yeah.
everywhere,
Right, right.
and we didn't.
Yep.
No project has an unlimited budget,
Sure, you
at
gotta
least
make
not that I've worked on.
Yeah.
And so we decided to use it in the place that made the most sense, which was the place that would be the hardest to change out the shingles. So yeah, we put our money where it made the most sense.
I think one other benefit of doing that also is that with the standing seam metal roof, we didn't actually have to penetrate into the roof system to anchor the racking. We were able to use a clamp that clamps right to the seam.
That's a really good point.
So from a
It's-
durability standpoint, that was a big positive as well.
Yeah.
Yeah, I'm glad you brought up durability. One last thing as we're in this
Yeah.
area is, you know, one of the small portions of LEED that doesn't get highlighted too much is durability and keeping water away from the house, keeping the house from rotting. Typically you'd think this is always built into projects, but sometimes it gets missed. So, you know, just I'm looking at it, you've got downspouts here directing the water. It looks like away from the house, maybe into the landscape.
Into a rain garden,
Into
actually.
into the rain garden, and then obviously I'm assuming it's sloped towards the lake here to keep the water down. So
Yeah.
maybe you can talk a little bit about that.
Sure. Well, a few things. So it is a very durable design. So it's got hardy plank horizontal siding, which is cementitious. It's not wood, so it won't rot. It'll stay just like it is. It's like putting cement on the side of your house. And we did use some of it's a cement-based wainscoting there of the stone. It's simulated stone from Borel to kind of keep the base of the building protected. Great long-lasting roof, again, is durability, great windows, and everything drains kind of away from the house. The patios are all sloped for positive drainage to keep everything moving away. And the other side of the house, the ground actually slopes away fairly intensely, so there's never anything that's going to be running towards the house. And you did mention, Brett, especially on this side where a lot of since the south-facing roofs all come this way, the water also drains this way. So we've been able to pipe that water underground, and it actually comes up into the rain garden. And the sand is the soil is sandy, so it's very pervious. So what we're trying to do is percolate all the natural rainwater right back into the aquifer, just like the house wasn't here. And we're able to do that through the rain garden.
Well, why don't we start heading on in and then talk a little bit more about the site and landscape.
All right.
Yeah.
All right. So this is the street side of the house. There's an emergency generator actually for backup power that's natural gas powered right there. And actually what you're looking at right now is the existing garage. So this site had an old cottage from the 50s that was on it. And what we were able to do is we were able to keep the existing garage, which is actually non-conforming and too close to the road, so we couldn't have ever rebuilt it where it is. And we put a new roof on the existing garage so that we could sort of tie it in with the design of the new house. But not tearing stuff down and taking it to the dump is another subtle, sustainable feature that sort of goes unnoticed, but it is an existing garage. So here's the front entry. Hardy plank siding, great doors, great windows. We threw a little steel here and there, you'll see as we tour around the house. And welcome.
And can you talk a little bit about some of the landscape design in here to the degree that you can?
Sure.
Well, maybe before you do that, why don't you reintroduce and just kind of say, like, we have a lot of viewers that have just joined us.
Oh,
So-
yeah, great. Well,
joining
thanks
us,
for
yeah.
all of you who are just finding your way into the Facebook Live feed for this project here. My name's Brett Little. I'm the executive director here at the Green Home Institute. And we're just south of Grand Rapids, Michigan, at this LEED pending platinum project. And we've got Michael Carlson here, who's the designer and architect, taking us through, as well as later we've got the builders Homes by True North and Greg Mulder from Kauffman Electrical going to be joining us as well. So we just kind of talked a little bit about the passive solar and the solar PV features of the home, and so if you missed that, you can catch it later. But we're entering the home now here pretty soon, and we're going to talk a little bit about some of the water conservation and landscaping features.
Great, great. So this was an existing lot, and the landscaping that you're going to see here is all native Michigan plants. So it's beautiful actually and full of color, plus it doesn't have a lot of watering needs. The plants can exist based on the rainfall that happens. The sod and the seeding has just happened, so the grass is not as nice as it will be in a while. But there's actually, if you look down the side of the house, it's actually, there's a turf block system, which is a plastic grid system that sits underneath the ground that you can't see, but it's a black waffle thing. They're black squares about 3 inches square that stabilize the ground, because this is actually where the boat launch is as it comes down the side of the house. So there's a stabilized subbase under all the grass, so that beginning and end of season we can bring the boats down to the lake and bring them back out without having to tear up all the grass.
Yeah, typically you usually see cement or a driveway or tracks leading down. So is this pretty unique, pretty standard when you looked into doing this?
Well, it's not anything crazy.
Right.
So it's not very standard, like as far as people don't do it very often.
Yeah, they usually put in cement or...
But it's a proven system. It works well. Actually, where Angela's standing and videoing, this whole front yard is actually all this turf block system. So when we have overflow, actually you can see it as the grass is, you can see it right there actually, as the grass is filling in. But the client often has a lot of visitors, especially in the beautiful Michigan summers. So you can actually park, when the parking fills up on the street, you can actually park on this grass. You can get 4 or 5 cars out here and on this stabilized subbase. So, but why have asphalt there or pavement there 365 days a year when you might use it 4 days a year?
Right.
So it's pervious. Again, we're trying to let the hydrical cycle of the rainfall go into the ground like it always has traditionally.
Very cool. Well, why don't we go inside? Will you take us in?
Yeah, sure. Sure. Welcome to the Birch Haven Residence. This is the front lobby. And one thing I want to point out while we're here is I had mentioned there was an existing cottage on the site, and part of the LEED process, and you get credit for it, is salvaging the materials and the demolition of the existing residence. So we did that. We had Habitat for Humanity out here. They reclaimed everything that they could, air conditioning, plumbing fixtures. They just had free reign. They stripped everything out of it that they absolutely possibly could.
Yeah, and you know one thing about Habitat, it goes to their local restore if they have a restore in the area.
Yeah.
So if you're ever doing a project that involves deconstruction, make sure to call them up, because they can take it and sell it, and someone else can use it, and it can benefit their organization. So.
Yeah. There was aluminum siding on the outside of the existing cottage, and we actually had neighbors come and strip all that siding off for them to build a cabin in the woods somewhere in northern Michigan. So that siding lives somewhere else in the state now. But the coolest thing that the original cottage had was it had knotty cedar, real knotty cedar paneling throughout. There was no drywall in the existing cottage. So what we did is we salvaged, and Alex and his team really salvaged and stripped the existing cottage down. And we actually reused the original knotty cedar siding in various places throughout the house. So this happens to be the existing garage, and it penetrates into the new construction of the house. And we wanted to sort of show that this was sort of the ghost of the cottage past. So we used the siding here, and it's so warm, and you can touch it and feel it, and it brings the old place back to life, the old cottage back to life. So I wanted to point that out. You'll see it on the ceilings when we go upstairs, and if Angela will sort of spin a little bit, you can see some of the really cool scallop soffit that we reclaimed from the old cottage.
Kind of like the upper trim.
Yeah, all that is exactly how it was in the old cottage. There was this sort of valance above the 90-cedar walls that would have been below before.
All right, well, why don't we head further on in?
All right.
Yeah. Good idea.
So maybe not the sexiest space in the house, but really cool space, really functional space, and there's a LEED credits associated with this. This is the mudroom, not your drab and dreary typical mudroom off the garage, but it's a great place to come in, take your shoes off, wipe your feet, hang up your gear, whatever it might be for what time of year it is, and there's built-in shoe rack, so you can store things down here, and you do it from the side door, and you can actually do it. We just walked in the front door, so you can kind of come and keep from tracking contaminants into the house by using this space.
Yeah, when you think in indoor air quality, usually it's ventilation that gets promoted quite a bit, but this is one small thing to keep, like you said, contaminants off your feet that come in from cars or vehicles. And I know for me personally, I've got a little toddler, so they're crawling around on the floor, and who knows what they're putting in their mouth. So it's just one other simple way that, when your mother always said, take your shoes off, like this really encourages you to do that, and it has health impacts or benefits.
Yeah, so, and it's simple. It couldn't be more simple.
Right. It doesn't have to stand out or look odd. So.
All right. So we're coming down the main entry hall, guest bathroom, laundry room. Just kind of give you a feel for the house. We really tried to do a house that was fairly contemporary in style, but very warm and inviting and comfortable. So it's not starkly modern, but it's very contemporary. You can see the beautiful wood 3-panel doors. Just really nice. Someone's phone ringing. Oh, the dryer's going off. All right. We're going to go here?
We're going to head out.
Okay, so we're going to keep heading to the front.
Why don't you tell us about, this is the main living quarters, main living room?
Yeah, welcome to the main living space, and you can see there's a lot going on in here. Above us is the roof that the photovoltaic panels are sitting on. So you can sort of see what I talked about, rotating the design by 20 degrees, and notice the wood beams are not, they're coming across at kind of a funky angle that you maybe wouldn't expect, but they're actually parallel with the roof structure. So the structure's simple, but the space ends up looking a little bit more complex than you would have imagined. So this is the great room, big vaulted space, beautiful views out to the lake, beautiful bar.
I'm looking at the fireplace here, which it's all electric, right?
Oh, it is a gas fireplace.
Oh, gas fireplace.
It's electric ignition, and it has
direct vent.
Yeah. So was there any
Glass
conversation about using a conventional fireplace versus a sealed direct vent?
There was lots of discussion.
Yeah.
Whether to actually have a fireplace or not was one discussion, because probably the most sustainable thing is to not have a fireplace.
Right.
But the client wanted a fireplace.
Yeah, from a health.
And I sort of wanted a fireplace.
From a health standpoint, at least one would be the open, conventional log fireplaces.
So it does have glass doors.
Yeah.
And it does have electronic ignition. So we got the LEED credits that we could.
Yeah.
But still having a fireplace.
No, it makes a lot of sense for something out here. So
It's a sealed unit, to reduce any possible air leakage and electronic emissions.
Yeah.
So Alex Goosen, Homes by True North here, the builders for this project. Maybe you can walk us through with Michael a little bit about the structure itself, what kind of materials you used for the thermal envelope and the structure, and maybe during the design process, what kind of different things you threw around to make this home energy efficient and airtight.
Sure. So originally we had looked at doing ICFs for the entire home.
Insulated concrete forms.
Eventually, though, we ended up deciding to use structural insulated panels, or SIPs. We felt that still provided the energy efficiency we were looking for, but also helped us reduce the cost somewhat from an ICF. The walls of the home, for the most part, are 6.5-inch structural insulated panels, with the exception of these tall walls. On the lakeside, we actually needed to use an 8.5-inch just to fit some of the beams and alveoles that were required.
Was that custom, or did you have to?
No, it's an option offered by the manufacturer. We used Muris SIPs. The R value for the 6.5-inch walls is 23, and for the 8.25 is 29. So still get a good R value. They are much more thermally efficient than a standard, framed wall. For the roof system, this large roof here, and as well as the roof you see across the balcony, we used 10.25-inch thick structural insulated panels. Just in this application with the tongue-and-groove ceiling, it worked very well. For the front or street side half of the home, we used an engineered truss system with 6 inches of closed cell spray foam up against the roof deck, so that the attic area up there is actually conditioned space, and the ductwork can all be run in conditioned space to reduce any heat losses that way.
Can you tell us about some of the materials and resource and environmental benefits of using SIPs?
From a waste standpoint, that's the big draw. The panels come from the manufacturer, pre-sized. Our installer actually just basically sets them up according to the drawing that the manufacturer provides. They have to make some cuts, but overall, the big benefit to the SIPs, aside from the thermal efficiency, is the reduction of waste in the framing process.
Yeah, it was pretty cool how the panels came out. They all had numbers on them, and they kind of went up in order. And they just started in one corner and worked their way around, and it was pretty cool how it all went up. It's really our first. We've used some SIP roof panels before, but we've never built a whole house out of SIPs, and I was very impressed. And the normal framing crew, normal carpenter crew, had experience in this, and they did it, and they knew what they were doing. And
we have a great framing crew we work with, and they've done some other SIP projects for us.
Yeah.
There is a slight learning curve with it, but overall it really is a pretty, user-friendly, I guess I'd say.
Yeah, it is. The reason, the part of the reason for the different panels was the thicker panels where there's a 2-story high unsupported wall where there's no second floor that connects to it. We had to use the thicker wall system structurally. And then where there is a second floor, where you sort of brace the floor, the 2-story wall halfway up, we were able to use the thinner panels. But the R values are great in both panels.
Why don't we quickly take a look at the kitchen, and you can talk to us a little bit about some of the other materials and resource choices you made, paints, type of content. What do you got going on in this house?
Boy, there's lots of stuff going on, and it's stuff that we use all the time, and it's stuff that you can buy everywhere now. So there's low VOC paint, the trim paint, the wall paint, everything is low VOC. All the glues and adhesives, everything that got stuck to something else, all the caulks are all low VOC. You can look at the flooring, very durable. There's lots of durability credits in LEED for homes. So the floors are all tile or bamboo, actually. This is beautiful bamboo flooring that runs throughout the house. Just gorgeous, very durable, long-lasting. Plus, it's a rapidly renewable material. Bamboo is a grass more than a wood, so we use quartz countertops. Again, just super long-lasting, no toxicity, no glues or anything like laminates and Formica sometimes have. Super energy efficient appliances, Energy Star appliances everywhere that we possibly could. And durability, like just these simple stuff like a tile backsplash that will keep the kitchen walls clean and last forever. Exhaust hoods. Red Lobby did the kitchen design actually out of Grand Rapids. They did a beautiful job with all the cabinetry in the bathrooms and the kitchen and some other built-in stuff. So
Is this hood range just directed out, or is it monitored through an ERV? Is it run through an ERV?
I don't know if it's, Alex, do you know if the hood runs through the ERV or is it direct exhaust?
It's direct.
Yeah.
Okay.
Yeah, so one real simple thing, but even in new homes we see it, where you get a hood range that sometimes is recirculating back at you, or venting into the attic, especially on remodels. And so just a real simple thing to draw out emissions, moisture. I see you have an electric stove, so
That was the client's choice,
Yeah,
so we could have used, there was an option to use natural gas,
Yeah.
but the client chose the preferred electric.
Right,
so,
yeah, and so if you use gas, again, more emissions. So just a real simple thing that's required in a LEED home that we still don't see all the time in normal construction, and being vented or not, recirculating back into the house. So.
While we're here, I mean, there's the lighting, that's all LED lighting throughout the house, the chandelier over the dining room table, all the recessed cans, all the undercount, everything is 100% LED, which is a no-brainer now. 5 years ago it was expensive, but it's really a no-brainer in residential and commercial. While we're here, the windows are all Anderson windows, which I know Anderson's a sponsor of the Green Home Institute, so we can give them a plug for sure. But they're beautiful. They're double glazed, low E glass, Energy Star windows.
Any reason you go with wood for more of the look?
Yeah, we went with the wood interior just to have the warmth of. We've used a lot of wood,
Yeah.
obviously, wood doors, but yeah, we wanted to use the wood trim on the inside.
Did you look at fiberglass at all as a trade-off? Or?
I'm a big fan of Anderson windows.
Yeah.
I'm not a big fan of fiberglass.
Okay.
And I'm definitely not a big fan of vinyl.
Okay.
Yeah, for other reasons.
Yeah, vinyl definitely is
for other reasons, but we did not look at fiberglass.
Yeah.
We really, I think, between the construction team and the design team, we really liked Anderson.
I think we were pretty set on the 400 series.
Great.
Right from the get-go. So.
Very good. Well, why don't we head upstairs then? And
All right.
Take a look at
All
the top
right.
floor.
Great. This is sort of a nice feature. This built-in cutting board, which Red Lobby came up with, is a really cool feature. It actually adds to the durability of the countertops because you always know where you need to cut. You never will cut on the solid surface countertops because you know this is right here for you. All right, let's go upstairs. Check out the view as you come up and meet the stair landing.
So one thing I'm noticing is all the hardwood floor. And I know, a lot of people love their carpet. You can get recycled carpet. You can get Green Label Plus certified carpet.
Yeah.
But what was the choice to mostly? I believe it looks like it for the most part. You've got all non-carpeted surfaces in here.
It is. It's 100% tile or bamboo. That's it. There's no carpet anywhere. And it was something that we would propose, and it's something that the client wanted to do as well. Carpet's just dirty by its nature, and it collects dust and dirt, and you have to clean it, and it's hard to clean it, really clean it, and get all the contaminants out of it. So this will be a much more clean, pollen, dust-free house forever, and that's what we decided to do. And we try to get away from carpet whenever we can convince our clients that it's the right thing to do. And anywhere that you come in from the house, you come in through, you saw the mud room or the front lobby, it's all tile. Laundry rooms are tile, bathrooms are tile, so anything that has any kind of wet space.
More water would be an issue.
Yeah, it's all tile, but it's a durability thing.
Sure.
And I love bamboo. It looks great, and it's rapidly renewable, and all those good things. Heavy glue laminated wood structure, swing roof, deck, and then the SIP panels are above this whole area, both in the lower ceiling where I'm standing and in the higher ceiling over the great room. Those 10.5-inch thick, I mean, they're amazing. They're just, you can imagine how much insulation is in that much foam, thicker than a commercial cooler would be in the walls of the foam. So just super panel system. And the structure set up to manage the spanning capabilities of the SIP panels. So there's efficiency in how far the beams are all apart from each other. So we coordinated on that so that, because the SIP panel it has limitations on how far it can span structurally. So. Again, all LED lighting. One feature, so the house does have air conditioning and heating, obviously. But if you take a look, so we're at the highest part of the house in the loft space, and if Angela will turn around and look up high, there's 3 windows up in the clear story. And this is the highest part of the roof, so the roof actually slopes up in 2 directions up here. And this is a thermal chimney, so those 3 windows are awning windows, so you can open them even when it's raining. And they're electrically operated, obviously, because you can't go right here. And you can open these up and open the windows up on the ground floor, and you can naturally ventilate this whole house, bringing in the air from below and letting all the warm air that's naturally convecting upward will all get exhausted out those 3 windows. So
between that and the fan, you can really reduce your...
You just don't need AC. If the humidity's down, you can cool this house passively without having to turn on the air conditioning. It's only really the humidity is probably the only thing that you can't deal with natural ventilation.
So this home's been being lived in for how long so far?
About 60 days now.
Okay.
So we're still working on things,
Yeah.
and tweaking things, and learning how to use the system.
And it's been a super hot summer here in Michigan and in many other places, as you all may know. That's why we're all here. So we'll hopefully we'll get some feedback to share with everybody about how some of that passive solar or passive cooling is.
We will, and we'll start gathering information on the solar panels and how much electricity they make and what percentage. There's Alex, you just installed it. What's the monitoring system for the PV?
Yeah, it's a gateway monitoring system, but I think, probably Greg.
Yeah, it's basically by Smart Homes, and one of the things we're working on is because you have a standby generator, when the generator is running, the PV cannot run at the same time, so we had to design a disconnect system for it. And we actually found that by doing a smart home system, we can actually do that. It also gives the advantage if the homeowner is away from the home, they can actually get on their cell phone, they can get to know that their house is on generator and the power's out. It also gives them the ability to change the temperature and change all the thermostat settings from remote locations, so if they're not in the home, they can actually do setbacks. So a tremendous amount of ability within that home monitoring system of what you can control and what you can do within the house.
And one of the disadvantages of typical solar without getting that backup generator is when the grid goes down, you can't pull that energy. So now you have that ability.
Is that a code?
Well, basically, with solar, you have 2 different versions. You have one that's grid connected that has to work in combination. It's much less expensive. And then the second version is you can actually do what's called a off-grid hybrid system, which can work with the utility or without the utility. And you have to have batteries, but there's a fair amount of expense to that. And a lot of times, rather than doing that, it's actually cheaper to put in a standby generator for those periods of time rather than doing this solar storage system.
And this particular site we knew had issues with power going out, thunderstorms and wind in the summer, and definitely they've had outages in the area a lot during the winter time. So the backup generator is another sort of subtle sustainability thing where you can actually stay here and live here even if your power's out in the middle of the winter. So you don't have to abandon ship and head for a hotel.
Right, and probably a little more affordable as of now than like lithium-ion backups.
Yeah, I mean the battery stuff is coming for sure, and we're looking at it, but still, for me, it's the battery stuff is not really here at a whole house scale level yet. Right. I think. But.
And we have seen the situation already with Greg and Amber here, where the power went out and the generator worked great.
Yeah, already in the first 60 days.
Yeah.
It makes the homeowner appreciate the money they spend on the generator right away, which is always good.
It was actually very fun because it happened while we were playing with the electrical system. So originally it was, what did I do?
You want to look at some water features?
Yeah, let's take a look around the rest of the top. Take a look at some of the plumbing and water structure features.
Take a quick peek down the hall. You can see some more of the reclaimed knotty cedar that we saw in the front entryway. We actually used it on the ceiling in the hallway here. So again, that's all just wood from the 50s. It was installed in the original cottage and reclaimed. So,
Wow.
But let's walk in around the corner here and we'll look at some of the water features. So this is a typical bathroom in the house. It's got low flow everything. It's got low flow faucets, low flow kitchen faucets, low flow shower heads. All the plumbing is Kohler, which we love to use. Beautiful, but it's not just beautiful. It's very water efficient. So really, all the shower heads are water efficient faucets. But the toilets are really cool dual flush, which I hadn't seen before. It's not the old 2-button thing. So if you look really carefully, there's a little tiny lever that gives you the half a flush, and then if you hit the bigger level, you get the full flush. So it's sort of subtle, but once you do it once, it comes so naturally. I think it's a beautiful design. Over the dual flush stuff. So again, it just looks like a normal toilet. Once you use it, you understand the half flush versus the full flush. So very cool. Water savings is pretty straightforward. We did look at things like cisterns and gathering rainwater, but it just ended up the math just didn't work. We couldn't really get the tank big enough. We couldn't afford a big enough tank to really manage it properly, so we opted not to.
Right. Yeah. Yeah.
Those are decisions, and it would be nice, but we just didn't do it.
Yeah, I mean, just the low flow toilets, the shower heads, the faucets, and Energy Star appliances really take you a long way.
Yeah.
Until we can figure out getting the cost down on some of those. We get calls for gray water system ideas all the time, and it's just like, did you start with a lower flow toilet? No.
Yeah,
Oh.
yeah.
So-
Gray water is especially challenging right
Yeah.
now. The systems you have to put in to support it,
Yeah.
it's really hard to make it work.
Okay.
And water's relatively cheap right now. 10
Yeah,
years from
especially-
now or 20 years from now, it might not be, but right now water is relatively cheap. So that's kind of the water side of it. You take a quick look. You're actually in the master, second floor master suite right now. There's actually master suites on both first and second floors, so the homeowner can choose to live where they want to live, and their guests can be in the other master. So it works out good that if you say you're elderly or you've had an injury, you're in a wheelchair, or you're on crutches, you can choose to live in the downstairs master. Or if you like the view from the upstairs, you can live up here. And there is an elevator, so the house is fully accessible, fully universal design compliant, so you can...
Yeah, I noticed that when we first walked in, there was a what they call a 0-step entrance.
Yeah.
Typically you've got to get through 2, 3, 4, 5 steps to get into a house, right?
Right.
And I noticed the bathroom was walk-in. I assume some of the turning radiuses.
The 5-foot turning radius for a wheelchair is built into all the bathrooms, even though it's not obvious, and there's not grab bars, but
Right.
you could put grab bars in. But the turning radius, all the doors are 3-foot doors everywhere in the house.
Right.
So you can get into every single room in a wheelchair or on crutches or however you want to do it. So
Yeah. And so I know for LEED there's an extra ID point for universal design accessibility. Did you guys look
we're
into
looking at
what
that,
those
and I think we're
requirements
going to
are?
get it. I think we're going to be able to get it.
Okay.
We will get that.
Yeah.
Yeah.
But universal design is huge, and I think it needs to get built more into projects because it's just something, it didn't cost you really any extra money or really any time as long as you just thought it through on the design side, right?
It didn't.
Yeah.
It didn't cost us. And why would you ever put a
Right.
2-foot 2-inch door in when you can put a 3-foot door in?
Yeah.
Really for almost the same cost. It's really almost the same. So
Right.
it really is just do it.
Yeah.
It's
And I know it affects all all ages and all people, even if they don't have a particular mobile disability.
Right.
You know, I look at myself. I lived in an urban inner, 2-story home in Grand Rapids, and I had a toddler, and just to get around that house was, really frustrating. And so I even saw in my own life then that to have a 0 step and to be able to get around is huge. And so I think we're excited to see folks like Michael and other designers just putting it in as a normal part of their plan. So.
All right.
We want to head down to the HVAC?
Yeah, let's do that.
Any questions from the crowd, Angela?
Not yet. Everybody loves the design.
If anybody wants to ask any questions, feel free to do so. But so Alex, why don't you tell us a little bit about the, obviously we just saw a lot of the passive features, which is the first thing you ever want to do when you're designing passive solar, passive cooling strategies. But at the end of the day, especially in Michigan, we're going to need heating and cooling systems to make a comfortable lifestyle. So Alex, why don't you talk to us a little bit about what's in this home?
Sure. So, in the design phase, we looked at a couple different systems. Originally, at one point, even we were looking at a hydronic in-floor radiant heating system. We ended up, after looking at a few different things, deciding to use a forced air system on the home. We have each floor has its own furnace and air conditioner. On the upstairs, you have a mechanical loft actually, which keeps those units kind of out of sight. We have 96% efficient ECM motor Lennox furnace and a 16-SEER AC unit for each floor. The home also has a Lennox HRV heat recovery ventilator to provide outdoor air, provide clean air into the home. The actual system itself is located in the crawl space under the home. What you see here is just the controller. That really, two reasons. One is that with a SIP home, it is required for warranty purposes because the SIPs create such an airtight home. But it also just lets the occupants have fresh air. Not such a big issue in the summer when they probably have windows and doors open a lot, but in the winter when you have the furnace running quite a bit and everything's closed up. So it's really a beneficial thing for indoor air quality.
And that's a heat recovery ventilator?
Heat recovery ventilator.
Yeah.
The water heater, we ended up using a hybrid heat pump electric system. Most of the time, this will operate just as a heat pump, which is extremely efficient, much more so than your traditional gas or electric water heater. It does have the option to have an electric backup, just in case the use rates are really high and it can't keep up with the heat pump. But it draws the heat right from the air. You actually notice stepping into the mechanical room that it's quite a bit cooler than the rest of the house, and that's why. So, Greg, maybe a little more.
Especially, one of the advantages, especially in a design like this, is when you're using the gas hot water heater. First of all, by not having to go with a gas hot water heater, especially in a tight home, you solve another issue of trying to get the ventilation in and out and basically doing a closed loop system. The other advantage, because it's a heat pump, it's actually using the heat that's already been created by the natural gas to heat the home as its source for its major heat, and then brings the balance up at a very high efficiency compared to just an electric element. The second advantage is in the summertime, and especially in a home like this where it's a warmer cottage, so that's when you're going to have all the people here and you're using a ton of hot water, is it actually is using the heat out of the home to heat that hot water. So it's actually providing, as the heat's being used for hot water, it's actually supplying air conditioning for the home. So it basically does a dual purpose that's kind of hidden within the technology, but especially in a site like this, really makes a lot of sense because of the usage factor.
Yeah, that's an awesome system. One thing actually to talk about a little bit the integrated design process is something that we use, and I was the architect, designed the house, but it was literally a team of people. Alex at True North and the subcontractors, everybody contributed. We had a charrette, but really early in the design process, we had a charrette where everybody in the team got together and we shared ideas on different systems and how to integrate the things into the design. So that's where we shifted from insulated concrete form wall construction to SIPs based on the contractor's recommendations. It actually cut the cost of the house about 10%. I remember it was significant to make the right choice on the envelope without sacrificing anything. And so it was it's such a team effort. So I would really encourage you to get everybody involved, get your lead provider involved right from the beginning, and get your sub-trades involved, and get your design team involved, and get your contractor involved. Don't design in a vacuum and then try to find a contractor to build it. Bring everybody in from the beginning and do it together, and it just makes the decisions so much easier. You end up with the right systems. You actually save money because you have input from a bunch of different people. So.
Yeah.
And one of the things that was kind of unique is that actually this house became a catalyst for basically development between True North and Green Home Institute, where we started taking not only looking at this house but also a couple other LEED homes that they've been working on, and developed, okay, how do we actually just start designing these things so we can look at integrating everything properly. So also some new technology. There's new air to water heat pumps that are much more efficient than some of these. We can do hydronic much easier. And looking at the whole envelope of how the energy usage, the balancing act, and what we've actually been able to do is develop new software and analysis tools, so that when in the design process you can actually take a look at, here's two different wall structures. What do they do to my energy? How does that affect what's happening based on which energy technology I'm using for heating and cooling, and how the PV works together. So it's really developed a really long marketplace that we're actually working on a lot of net zero homes where we can actually make them cost, so they actually reduce the cost of ownership first year. And so it really was a catalyst for really a process that's been really valuable in the marketplace.
Yeah. Is this, Michael, is this home aiming to be near zero energy? Is there a goal or a strategy there?
Well, there isn't necessarily a goal. It wasn't one of the primary goals of the project, but it is set up to have enough roof area to be net zero at some point. It's a first cost. How much PV do you want to buy up front?
Sure, yeah.
We can certainly probably double or even triple maybe the PV, and we can certainly get to net zero.
Right.
But we did, the strategy was to do everything passively, the things you can't ever change.
Right.
And do those right, and then we can work our way to net zero. And now that we're up and running and we can start gathering data, we're going to, and often we have some net zero projects. You work your way to it, you sort of let's try to get 80% there, maybe it's the start, and then you work your way towards it, and that's what we're going to do.
Yeah, you work your way towards the goal. So you worked with your energy modeler in the beginning, which is a really good idea, right? Getting that preliminary modeling, not just having them come at the end and fact check everything. That's one real big value of having that HERS index rater, which is a required part of LEED.
We should talk about HERS on this.
Yeah, so the HERS index rating on this house is, what did you end up coming in at?
It's 26. Yeah. So it's 26. So it's 74% really more efficient than normal construction.
Yeah, normal construction, and even when this house was permitted, I think the Michigan code was around 86 on average.
Yeah.
And now the new Michigan code is around 55. So this home is already way beyond the code that we'll get to in a while. It's a future home. Right?
So it's twice as efficient as the new code.
As the new code, yeah.
Yeah. So that's what it really comes down to, is the HERS rating. You get lots of LEED credits for it.
Right.
But it makes all the difference in the world for performance. So we were really pleased to get to 26. So that means we don't have that far to go to get to net zero even right now.
I was going to say, a lot of homes, we've seen homes in the 30s, 35 that have operated correctly. We're not asking people to live in the dark or freeze to death. Could get to zero energy without having a HERS index rating of 0. So a lot of people think you have to hit that 0, which is very expensive sometimes. So you're really in a sweet spot where depending on if you work with your clients, you might be able to get there. You might be able to get close.
Yeah, and the HERS is all about performance and the right specs and
Yeah.
the right design, and it's all about installation too. It's all about sealing up, putting the windows in right and putting the SIP panels in right and having the right equipment inside. It's not just the design. Design team can't create the HERS rating.
Right.
We can target it, but it's all about the trades in the field that are going to really make the HERS rating happen.
And with
It's
folks like
awesome.
Homes by True North, who do a fantastic job building, and then you just have that HERS rater come in and just fact check a few more things, and if one thing's missing, that can get corrected before everything is done and contracts are signed and everybody's on their way. So, we're coming to the end here.
Walk out. You want to walk out?
Yeah, why don't we head out and take a look at the beautiful view on our way out?
You can see all the windows to take advantage of the view. This is a west, a little bit north of west view from this side, and you can see the lake. And
I wanted to give everyone an opportunity too, as we're wrapping up, to please send questions or comments.
yeah, great. Yeah, we can answer those at any time in the future, and we will get this up. So it can be watched again, right? We'll figure that out.
Yeah, definitely. We'll have this recorded so you can access it later. For those of you looking for continuing education, watching this on demand, make sure to take your 10-question CEU test as well, so you can pick those up. For those of you watching live, a short survey should have been sent out to you. If not, let us know. We'll send that out, and you can pick up your continuing education that way. Again, my name is Brett Little. I'm the Executive Director at the Green Home Institute. We're a nonprofit that oversees LEED certification in the Midwest, does training and education on that. And then, Alex, where can people find more information about you guys?
You can just do truenorthhomes.net, the website. We also have a Facebook page. If you search True North Homes or Homes by True North on Facebook, it will come up.
And where do you guys build around?
We're based in Grand Rapids. We go as far south as South Haven, Kalamazoo area. We have gone as far north as Traverse City, but that's on the far end of where we would go.
Right.
So all along Southwest Michigan, really.
And tell us.
Kauffman Electrical Equipment, our website is steadypower.com. Our primary business, we've been in generation for over 65 years, so our primary is backup power systems, UPSs, generators, and you see that on the website. The solar, we're starting to develop further on that. And then we also have been looking at heavily into how to make everything look at these as integrated systems, and that's been a process that we've been developing over a couple years ago. One nice thing is a few years ago we got a large grant for to build a microgrid for the military, and so a lot of these stuff that we're actually using in these houses is actually information that was learned on that government research grant.
And where can more people find information about this project, about what you guys do, where you design, where your projects are?
Sure. So Carlson Studio is at carlsonstudio.org. You can find all the pictures of this project on our website. It's called the Birch Haven Residence. So if you go into the residential portfolio, you'll see this will come right up. And you can see construction photos, the reclaim of the existing cottage photos, site construction, everything. There's all kinds of great information on there, including descriptions of the design process and the charrette process and all that stuff. So we work and we're licensed in 5 states in the Southeast U.S., Florida. We have a Seattle office and Michigan, so we're interested to do work all over the country. It's a little bit easier for us from the design side to work all over the country than the contracting side. So we're interested to work anywhere you have a house.
Did we get any questions that came through?
No
So
questions.
it sounds like we did everything correct. There's no question. You've answered all of them.
We've
So,
gotten some lives.
when do we anticipate certification?
Weeks, I think,
Weeks.
the most.
All right.
It's on the verge. We're
Yeah.
wrapping up the final
we're
credits.
Wrapping up
Yeah.
and
Yeah.
within 1 to 2 weeks.
So once that comes out, we'll have some more information on anything else we learn. We'll share that with everybody. Profiles will be going out.
Yeah, we can share the final credit,
Yeah.
point credits, and what we got and what we didn't for
Yeah.
sure.
And you can go to our website, greenhomeinstitute.org, and check out a project profile on this as well. So I want to thank everybody for their time today.
Thanks,
for
Brad.
the
Thank you.
yeah, and thanks for the clients for opening up their beautiful house. And I really want to go swimming right now. I'm getting back into the water. It's like 80 degrees out here. So it's a beautiful day. Weekends here though. So thanks everybody again. I'm Brett Little, Executive Director at the Green Home Institute. Our website is greenhomeinstitute.org, and we'll look forward to seeing you all on our further education series that'll be kicking back up here soon. So, thank you.